Hello, welcome back for lesson 2.4. There's the Hazel cam. Hazel. Hazel. Hi, honey. She's tired again. Anyway, we are going to be talking about linear inequalities on this lesson. And I want to go through a couple of properties that are important because when we talk about inequalities, we're talking about the less than symbol, the greater than symbol, and then less than or equal to and greater than or equal to. And so now we're not just talking about where an equation, one side equals the other side. We're talking about where one side is less than the other side or one side is greater than the other side. And so there's some properties that hold true and some that change up a little bit. So the addition property that we learned back in, I think, 2.1 when we were solving, first started solving equations, it says if A is less than B, then A plus some value C is still going to be less than B plus that same value C. So let's do it with some numbers. If 2 is less than 3, we know that's true, then 2 plus 7 will be less than 3 plus 7, and 9 is less than 10. So that is true. Let's see if it also holds for subtraction. So also, if 6 is less than 9, then 6 minus 2 should be still less than 9 minus 2. So 4 is less than 7. And that is still true as well. Okay. The multiplication property, and this is on page 151-ish. Really 152. So if A is less than B, then A times C is going to be less than B times C only if C is positive. Okay, so let's do an example here. So let's go with we know that 2 is less than 3. And then let's multiply by 7. So then 2 times 7, is that less than 3 times 7? And yes, 14 is less than 21. So that is still true. Because 7 is greater than 0. Okay, let's see what happens when C is less than 0. So if A is greater or less than B, then what happens when you multiply A times C and B times C if C is less than 0? So let's do 2 times 2 is less than 3. Let's do that one still. And this time, let's say C is going to be equal to -7. It's less than 0. Okay. So if we say 2 times a -7 and 3 times a -7, we get a -14 and a -21. And so now it means that -14 is actually greater than a -21. So it looks like when you multiply by a negative or divide by a negative, then your inequality symbol flips. If you add and subtract, it will stay the same up here. But if you multiply and divide by a negative only, that's when it flips. So we have to be cautious about that today. So there's some good directions on page 153. The other thing I want to stress is when we get our answers, so our solutions are always going to be our minimum solution, comma, our maximum solution. And we're going to use a negative infinity or positive infinity to show where it's endless. In the negative direction or endless in the positive direction. They always get a parenthesis around them. If it's a strictly less than or strictly greater than, they also get parentheses. Okay, if we have a less than or equal to or a greater than or equal to where we're including the endpoints, then they get a bracket on whatever side it's referring to. So you're going to see this as we give solutions today. Okay. So let's go to page 157 in the course or in the book here. 157. We're going to look at problem number 1 first. It says solve each of the following inequalities and graph each solution. So to solve for x, we're going to divide by 2. And because we're dividing by a positive, then our inequality does not flip. So x is less than or equal to 3. So let's just write that in words. X is less than or equal to 3. So our number line, we've got 1, 2, 1, 2, 3. So there's 0 here. So here's 3. And because it's less than and we're including it's equal to 3, we're going to shade in this circle mark on the number line for 3. And then everything less than that is what we're including. So we're going to shade with this squiggly to show I'm shading it that way. And it doesn't say to include an interval notation, but I'm going to for my answer. So because I can go limitless to the left, I'm going to have a parenthesis and a negative infinity. And then my maximum, right? So we said we were going to do our minimum value and our maximum value. So I can go as far as a negative infinity is the minimum value, but the maximum value we said is going to be 3. And it's less than or equal to, so we're including it. So we're going to use a bracket on that 3. Okay. Now number 2, 5x is greater than or equal to negative 15. Again, we're going to divide by 5 here. And so we get x, and we divided by a positive, even though this is a negative 115, the number we're dividing by is a positive. So we do not have to flip our inequality. So that becomes 115 divided by 5 is 23. So we're going to have 0 down here, and way up here, we're going to have 23 somewhere. And it's greater than or equal to 23. So because we have an equal to, we're going to give it a colored in circle, and then it's greater than that. So it's going to shade to the right of that. And then my number line kind of guides my interval. So my minimum value this time is the 23. And I've got the equal to it. So it's going to include it with the bracket. And then my maximum value is that I'm endless out here on a positive value out here. So it's going to be a positive infinity with a parenthesis. Now, my next one has a fraction. So it's got this 2/3, negative 2/3 x less than a negative 8. Because I have a fraction involved, I'd like to eliminate the fractions if I could first. So I'm going to multiply through by a 3 and a 3 to every term. So my 3's cancel, and I have a negative 2x less than a negative 24. And then to solve for x, I'm going to divide by a negative 2. So I'm always treating it as if there's an equal sign there, until I divide or multiply by negative, which I am this time. I'm dividing by negative. So I'm going to circle that to remind myself that I'm changing it to a greater than. And then if I have to look back and I know I circled it and I have a new one, I can see what I did and why I did it. So my answer is x is greater than a negative 24 divided by negative 2 is a positive 12. So we have 0 on my number line and 12, and it's greater than 12. And because it's not greater than or equal to, it's just greater than, it's an open circle, and it's greater than, so I'm going to shade to the right. And so the smallest my x could be is 12, but I'm not including that value. I'm getting really, really close to it, but I'm not including it. So it gets only a parenthesis this time instead of a bracket like up here. And my maximum value it could be is a positive infinity with a parenthesis. So those were some simple equations to solve for it. And my last one here, well, not for the lesson, but on the page, is I'm solving for x in this inequality. And so we're going to undo this subtraction first by adding 5. And remember, we can add or subtract all that we want to. It won't change the symbol. It won't flip the symbol. And then we have to divide by a negative 2. So because we're dividing, I'm going to circle that and change it to a greater than or equal to. So x is greater than or equal to 20 divided by negative 2 is a negative 10. And so I'm going to draw my number line. There's 0. A negative 10 is to the left of 0. And it's a greater than or equal to. So I'm going to color in the circle. And I'm going to shade to the left. And then the smallest it can be is a negative infinity. And the biggest it can be is a negative 10. And it gets a bracket. So hopefully this is helping you with solving some basic equations, but you're also now adding this little piece here with the inequality. So let's look at the next page. I'd like to look at problems 30, 34, and 44. 30, 34, and 44. And 30 has some fractions involved. And so to eliminate the fraction, I say we multiply through by the least common denominator, the least common multiple, which would be least common multiple, which would be 3 times 2 or 6. So we're going to multiply every term by 6. And so we get 6 times a negative 2 is negative 12. 3 goes into 6, 12. 2 times, so we have plus 2x greater than or equal to. And then 2 goes into 6 3 times, so we have 3x minus 5 times 6 is 30. Then, when we're doing inequalities, especially, I know when we started solving equations, I mentioned that I like to have my variable on the left. And that's because I just like to read x is something. X is less than or greater than something. So I like to have x on the left. So let's move our x's to the left. So we're going to subtract 3x. We'll do that first. So we have 2 minus 3 is a negative x greater than or equal to negative 30. And then I'm going to get my constants to the right. So those cancel. We get a negative x is greater than or equal to a negative 18. And we're solving for x, but right now x is negative. So we really just have to make it the opposite sign that it is. So by dividing by that negative 1. But because we're dividing by negative, we have to flip our symbol. So x is really less than or equal to a negative 18 divided by a negative 1 is a positive 18. And the answers that make it true are including, so it's less than or equal to 18. So I get to color in the circle. Less than or equal to 18. And so my interval is going to be, it can be all the way out to a negative infinity, and the maximum it can be is 18, and we're including it, so it's a bracket. No fractions on 34, but we have this parentheses. So let's go ahead and distribute the negative through. So it's a negative a, positive 2 minus 5a. Let's combine all of our a's here on the left. So we have a negative 6a plus 2 less than or equal to 3a plus 7. And again, I like to have my variable on the left, so I'm going to subtract 3 a's to move them to the left. So they're negative on this side. So negative 9a plus 2 less than or equal to 7. And then we're going to subtract 2. So negative 9a less than 7 minus 2 is 5. And to solve for a, divide it by negative 9. And I apologize for the pounding. Somebody's here working at our house. And so because we divided by a negative, we're going to circle this and we're going to flip our symbol. So a is actually greater than a negative 5/9. So let's just go here. We've got our 0 and negative 5/9. It's going to be to the left somewhere. We don't have to worry about exactly where it is, but we just want to make sure we know that it's left of 0. And it's a strictly greater than, so it gets an open circle, and it's greater than, so we're shading to the right. And so it's open parentheses, our very minimum value is a negative 5/9, and it can be as positive infinity is our maximum. And then 44. So 44, we have some fractions again. So to eliminate the fractions, we're going to multiply by the least common multiple. So 4 is a multiple of 4, and it's also a multiple of 2. So we can multiply through by the 4. Green. So I'm going to multiply here by 4. I'm going to multiply here by 4, and I'm going to multiply here by 4. So that cancels out, and we get 1x. And then 2 goes into 4 2 times. So we get minus 2 times the 3x plus 1. And then 2 times 4 is 8. And then we're going to go ahead and distribute our negative 2. So we have just 1x, or just x is fine. Minus 6x minus 2 greater than or equal to 8. And I'm going to combine my like terms. So x minus 6x is a negative 5x minus 2 greater than or equal to 8. So minus 5x greater than or equal to 10. And then I'm going to divide by that negative 5. to solve for x. And because I divided by a negative, I have to flip it. So x is actually less than or equal to 10 divided by a negative 5 is a negative 2. And we have to draw our number line here. So our number line, there's 0, and it's less than or equal to a negative 2. Negative 2 is here, and it's including, it's less than or equal to, so I get to color in my circle, shade in my circle, and it's less than that negative 2, so I'm going to shade to the left. And so my minimum value it could be is that negative infinity, and the biggest it can be is that negative 2. And because we shaded it in and there's a less than or equal to sign, it gets a tough, hard square bracket. These two definitely entailed a little bit more work. 2 more problems for practice here. We're going to practice doing inequalities with 2 variables. So 48 and 54 are the 2 that we're going to do. And they're both equations in 2 variables, and we're solving for y. So I'm just going to circle y here. And y here. So that means we need to get the 3x to the other side. So we're going to add the 3x. So we have 2y less than 6 plus 3x. And then we get to divide by 2 to solve for y. And that means every term divides by 2. So y is less than, we divided by a positive, so we don't have to change our inequality symbol. So y is less than 6 divided by 2 is 3 plus 3 halves x. And the last problem, go ahead and write that down. Solve for y. So we're going to move this 4x to the other side is the first thing we're going to do. So it leaves us with a negative 2y greater than or equal to negative 8 minus 4x. And then we have to divide by a negative 2. Each term needs to divide by a negative 2. And because we're dividing by a negative, we have to flip our symbol. So negative 8 divided by negative 2 is 4. A negative 4 divided by negative 2 is a positive 2x. Wow. So on these, we are going to, we just solved here. We're not actually going to show on a number line. This is just our symbolic solution here. So that's all. Catch me back for lesson 2.5. In 2.5, we're going to get into compound inequalities. So inequalities that have an or an and. And then 2.6 and 2.7, we're going to look at absolute value equations. So those are super fun too. So I'll see you then.